Trigonometry, Chapter 8, Section 3, Graphs of the Sine and Cosine Functions. Many things in daily life repeat with a predictable pattern. Because sine and cosine repeat their values over and over in a regular pattern, they are examples of periodic functions. And we see a lot of periodic functions. A heartbeat would be a periodic function. Weather patterns are periodic, and sine and cosine as well. A periodic function is a function f such that f of x equals f of x plus np. For every real x in the domain of f, every integer n, and some positive real number p. The smallest positive value of p is the period of the function. In other words, you're going to get the same y values over and over again at set intervals for x values. And this is the graph of the sine function, and we can see that as s increases, and s would be the value of the angle. In fact, we're going to change that from s to x. But as x increases, the y value is going to go back and forth between 1 and -1. And the graph is continuous. You can draw it without lifting your pencil over the domain of all real numbers. The range is -1 to 1. The x-intercepts are the form n pi, where n is an integer. In other words, multiples of pi, 0, pi, 2 pi, 3 pi, 4 pi, and the negatives that match those are going to be our x-intercepts. The period is 2 pi. In other words, from 0 to 2 pi represents one full cycle, and then it repeats over and over and over again. So every 2 pi, you have the same cycle that gets repeated. The graph is symmetric with respect to the origin, and it is an odd function. And the graph of the sine function is also called a sine wave or a sinusoid. And when you draw a comprehensive graph, you need to have at least one period of the graph, and you need to show the extreme points. You need to show the highest and lowest points. The graph of cosine can be found much in the same way the graph of sine can. Notice that the graph is the graph of the sine translated pi/2 units to the left, so it's just a little bit of a shift to the left there. The graph of the cosine, like the sine, is continuous on the domain of all real numbers, and the range is -1 to 1. The x-intercepts are of the form pi/2 times 2n plus 1, or another way of thinking about it would be odd multiples of pi/2. For example, pi/2, 3 pi/2, 5 pi/2, etc., and the negatives that go along with them. The period is 2 pi, just like sine, and the graph is symmetric with respect to the y-axis, and it is even. So sine is odd, cosine is even. Okay, now we're going to look at the graphs that are stretched or shrunk either vertically or horizontally, or both, and compared with the graph of the original functions. So what I want you to do is graph this y equals the 2 sine of x and compare it to the graph of y equals the sine of x. Pause the recording, give this a try, and resume to check your answer. Okay, so really you just needed to graph it, and looking at the two, both on the table and on the graph, it's pretty clear that the only change is the range. The x-intercepts have stayed the same, the period has stayed the same, it's just that our low point is now -2 instead of -1, and our high point is now 2 instead of 1. And this really shouldn't surprise us at all, because a number out in front of the function, like the 2 is going to stretch it vertically. So it's not affecting the zeros, but it is affecting the amplitude of a function is half the difference between the maximum and minimum values. For the sine and cosine, the amplitude is 1. The highest is 1, the lowest is -1. 1 minus -1 is 2, and half of 2 is 1. The graph of y equals a sine x or y equals a cosine x, where a is not 0, will have the same shape as the graph of sine or cosine, except that the range will be -a, +a, and the amplitude will be a. So that number out in front of the sine or cosine is going to tell us what the amplitude is. If there's no number there, then the amplitude is 1. No matter what the amplitude, the periods are still 2 pi. So when you multiply a number out in front, it's not affecting the period. But now we're going to look at what will affect the period, and notice what we're doing now. We're doing y equals sine of 2x. And here's a table of values for that from 0 to 2 pi. Okay, and you will notice that this time the period has been affected. Normally we get in one full cycle between 0 and 2 pi, but here we are getting in 2 full cycles. And so the 2 has actually doubled the number of cycles inside of 2 pi. So 1 complete cycle occurs in pi units, not 2 pi, so the period is pi, which, by the way, would be 2 pi, the cycle of just plain old sine, over 2, over the number in front of the x. Now, knowing that, what would you expect about y equals the sine of 4x? Well, we're going to look at that next. But putting together what we just learned about 2x, think about what you would expect to see. How many cycles would you expect within 2 pi? Or better yet, what do you think the period is going to be for the sine of 4x? Okay, well, here's the table. Now, notice this table only goes to pi. We're fitting in 2 cycles in pi, and pi is half of a full cycle for sine or cosine. So we're actually getting in 4 cycles, which means that we're getting in 1 complete cycle from 0 to pi over 2. Now, how do we achieve that? Well, it's 2 pi, the normal cycle, divided by 4, the number that is in front of the x. To find the period of y equals sine bx or y equals cosine bx, we solve the inequality for b is greater than 0. So we say, okay, 0 is less than or equal to bx, which is less than or equal to 2 pi. If you divide everything by b, you get that x is between 0 and 2 pi over b. So our period actually becomes 2 pi over b. So what you're going to do when you graph, the easiest way to do it is you divide the interval into 4 equal parts, and to get the values for which y equals sine bx or y equals cosine bx is -1, 0, or 1. And these values will give you the minimum points, the intercepts, and the maximum points. So what you'll do is you'll find the period, you will indicate where the period ends on the graph, and then between 0 and that point, you will mark it off into fourths. And the fourths will help you draw the graph. Is greater than 0, the graph of y equals sine bx will resemble that of y equals sine x, but with a period of 2 pi over b. Same thing for cosine, 2 pi over b for the period. So give this a try. Try graphing this equation over one period. Try doing this by hand without using your calculator. Pause the recording, give this a try, and resume to check your answer. Okay, so the period is 2 pi over 2/3, which is 3 pi. So what we're going to do on our graph is we're going to go from 0 to 3 pi. We are going to mark it off into fourths. We'll put and we know that our cosine starts at 1, and the amplitude hasn't changed here, at 0, and it's going to end at 1 at 3 pi. And then we're going to divide that interval into fourths, and then mark the high and low points and connect them into a graph. On your graphing calculator, you would use a window from 0 to 3 pi, and we use -2 to 2, even though it doesn't go there, just to give you some room. The x scale is 3 pi over 4. Why 3 pi over 4? Well, that's what you get when you divide 3 pi by 4, and it will make sure that the marks on the graph coincide with the marks that we put on our graph sketch. Okay, so to graph y equals a sine bx or a cosine bx, first find the period. Do 2 pi over b, start at 0 on the x-axis and mark off a distance of 2b, and divide that into 4 equal parts. Evaluate the function for the 5 x values resulting from step 2. In other words, put those x values, those 4 x values, or actually 5, into the equation and get your y value. Now, this is actually one way of doing it. The points will be the maximum, minimum, and x-intercepts. Plot the points and join them in a curve. And then draw additional periods as needed so you can add on to the graph as you need. So we're going to graph y equals -2 sine of 3x. Pause the recording, give this a try, and resume to check your answer. Okay, our period is 2 pi over 3. We divide that interval into 4 equal parts, so divide 2 pi over 3 by 4, and we get 0, pi over 6, pi over 3, pi over 2, and 2 pi over 3. And then when you put those into the equation, they kind of did it in steps here. You could see the results at the bottom, 0, -2, 0, 2, and 0, which shouldn't surprise us because that is the amplitude. plot the points, and by the way, notice what the negative has done. It has actually flipped the graph upside down around the x-axis. And there's our graph. Now we can also translate these graphs. A horizontal translation, the graph of y equals f of x minus d, translates the graph d units to the right if d is greater than 0 and d to the left is d is less than 0. This is actually following the same pattern we've been doing. If you have a number that is added or subtracted to the x, it is going to shift the graph horizontally, and it will go right if it's plus a number, or sorry, it will go right if it's minus a number and left if it is plus a number. A horizontal translation is called a phase shift, and the expression x minus d is called the argument. Vertically, what we're going to do is we're going to add or subtract a number to the function itself. So after you take the sine or the cosine of whatever, then you add or subtract a number, and it's going to work like it's always worked. If you're adding a number, it's going to shift it up, and if you're subtracting it, it's going to shift it down. All right, now let's try this. We have a shift. This is going to be a horizontal shift of pi over 3 to the right. Pause the recording, give this a try, and resume to check your answer. All right, so one way of doing it is for the argument to result in all possible values through a period, it must take on all values between 0 and 2 pi inclusively. So we need to find an interval of 1 period. We're going to solve the inequality. So what we're going to do is say 0 is less than or equal to x minus 3 pi, or sorry, pi over 3, which is less than or equal to 2 pi. Add pi over 3 to all parts, and we get that 1 period is going to go from pi over 3 to 7 pi over 3. So we're going to make pi over 3 our starting point and 7 pi over 3 our ending point. We're going to divide the interval in between into 4 equal parts and find those values. And then we're going to find the y values when x achieves those number key points. And putting them into the equation, we find out where it's 0, 1, -1, and 0. And then here you see the original graph of y equals sine x and the translated graph. Now, as I said, that was one way of doing it. Another way of doing it is just to use the horizontal translation. So what you do is you realize that x minus pi over 3 means that the graph will be translated pi over 3 to the right compared with the original graph. So what you do is you graph the original function, graph y equals sine x, and then you shift everything over pi over 3 and you graph the appropriate translation. Okay, so when we're trying to graph one of these functions, and here everything is put together, we have c plus a sine b x minus d, or cosine. This is translations, shifts, amplitude, period, everything's been thrown in here. Here's what we're going to do. Now there's two ways we can do this. One is, first of all, find an interval whose length is 1 period, 2 pi over b, by solving the three-part inequality. 0 is less than or equal to b times x minus d, which is less than or equal to 2 pi. So you solve that for x, and you find where x is going to start and where it's going to finish. You then mark those places on your graph, and you divide that interval into 4 parts. You evaluate the function for each of those values, and those are going to be the maximum, minimum, and the intersection points. Now, here's the thing, though. It's going to intersect the line y equals c, because c is going to indicate a vertical translation. So you're going to actually use whatever that c is as your base. That's going to be where the intersection points will hit. Plot the points and then join them in a curve, and then draw additional periods as needed. There's another way to do it, and I'll be honest, this is the way I tend to prefer to do it. First, what you do is you graph y equals a sine bx or a cosine bx. In other words, get the basic function in there with the amplitude and the period adjusted. The amplitude will be the absolute value of a, the period will be 2 pi over b, and then use the translation to get the final function. So go ahead and graph with the amplitude and the period correct, but not the translation, and then move it up and over or down and over wherever you need to move it from there. And personally, that's kind of the way I like to do it, but whichever method works best for you is fine. So let's try one of those methods. here on this example. So graph this equation, pause the recording, give it a try, and resume to check your answer. Okay, so looking at this, we see that we have an amplitude of 2. We have a period of 2 pi over 4, that's the number out front of the parentheses, which is pi over 2. Notice that we factored that out. You'll notice from the original problem, we made sure to make it look like the form for the equation. We need to translate it 1 unit downward and pi over 4 to the left. And we're going to start at the x value of negative pi over 4. And we're going to end at positive pi over 4. And there you see the graph. Now again, another way of doing this is to graph it and then do your translations. Make sure you've got the period and the amplitude and go from there. Okay, one last thing. We're going to look at determining a trig model using curve fitting. And what we're going to do here is we're actually going to use the function in our calculator that lets us take data and find a curve that works for it. So if you read over this problem, we have the maximum monthly average temperature in New Orleans is 82 degrees. The minimum is 54 degrees. You have a table there showing the monthly average temperatures. And then you have a scatter diagram or scatter plot. And it looks like, could very well be a sine curve. So we're going to see if we can find a sine curve that will fit it. And we're going to do these things. A, use only the maximum minimum, determine a function. So first of all, see if you can come up with a function without using your calculator. And x is going to represent January, which is 1. B, then what we're going to do is we're going to graph for a 2-year period the equation we got with the actual data values on the table. And then you're going to use the SINE regression feature of the calculator to determine a second model, see how close you were. Okay, so pause the recording, give this a try, resume to check your answer. Okay, so to find our amplitude, we're going to take the maximum and the minimum average temperatures and subtract those, divide by 2, and get 14. So that's half the distance between the two, and that'll be our amplitude. For C, which is the kind of the baseline that the curve wraps itself around, we are going to take the maximum and minimum, and we're going to average them. So we're going to find the middle of the two, which is 68 degrees. So that's going to be kind of my 0 line is 68. And my amplitude is going to be 14. So I've got A now, and I've got C. The temperatures repeat every 12 months. So one cycle is 12 months, if you look at that. And let's see, it says that B is 2 pi over 12, which is pi over 6. The coldest month is January, which is 1, and the hottest month is July, which is 7. So we should choose D to be about 4. How we're getting that is that we are subtracting 1 minus 7 is 6, half of 6 is 3, and from if x is 1, then when we move 3 over, we got 4. So 4 is right in the middle of those two. So that's going to be D, and it's actually not going to be exactly D, and we're kind of just trying to figure out what it is. So they did a little trial and error, and they got 4.2 for that. So here we have it. Our equation, the graph. It says the figure also includes the graph of y equals 14 sine pi over 6x plus 68 for comparison to show the horizontal translation. So it's showing it starting at 0 and then starting at 1. And that's putting in our curve. And then to do the regression, what you're going to need to do is you're going to need to go to Stat Edit, and you need to put the numbers for the temperature in a list. And then you're going to go Stat Calculate, and you're going to choose a SINE regression. It's S-I-N-R-E-G, and hit Enter, and it will give you an equation. If you look at the screen, it's going to be similar to the screenshot you see there. And then you can either, you can copy the equation down and put it in Y1 and graph it with the data. So we have our graph, and then we have the equation that was given there, and our graph is really not too far off. We did a pretty good job with it. Okay, the rest of this is some practice problems, so if you will go through these, pause the recording and try them, and then resume to check your answer, and do this until the recording ends.